Okay, it does work. Yeah. Okay. 3-5 working with sets. When was the last time you heard me use the word set? It was a while ago.
Yeah, it was like.
When was it? What was the context? Raise your hand if you have a. 1 dash what?
I think it's 1 dash. This is the lesson that I think I was sick for, and then that's why I did that on the test. So.
Okay.
Oh,
1-4, I'm gonna guess.
1-4?
I just remember sets and subsets.
When?
I remember. Oh, set. 1-9. Numbers. Sets and real numbers.
What were we talking about? And I used the word set. Quincy?
Like real numbers.
Yeah. When we talked about rational numbers, real numbers set, and rational numbers and natural, whole numbers, integers, and all that, we talked about set. All right? So, all right. So a set is a distinct collection of distinct elements, and that would be an integer set going from negative infinity to positive infinity. That would be a whole number set, right? Starting at 0, going all the way to infinity. Now, the whole number set is also a subset of the integer set. We're going to talk about this a little later, but do you want to tell me what it might mean? Alex?
Like a certain portion of a set. So
Okay, a certain portion of a set. Correct. So, in other words, you can fit the entire whole number set into the integer set. Okay. Now, or if I had a set A, B, C, D, E, F, G, H, I as its elements, and I had set B with A, E, I as its elements, then set B would be a subset of set A, right? Okay. Good. Now, there are two ways to write sets, right? The roster form is the most commonly used form, and that's the form that you saw on the previous page, where you have the double brackets, also known as braces, and you have the numbers or the elements listed inside the braces. Right? So it lists the elements in a set and written using double brackets or braces. Now, there is also something called the set builder notation. What this does is it describes, instead of listing every element in the set, it gives you a description of what is part of that set. Okay? You have X, and then there's a line, and X is a perfect square. How do you read this? Or what is this notation telling you? Does it give you any information, Natalie?
Well, if X is like, variable standard for a perfect square, then the numbers that must be part of that set should be perfect squares.
Okay, so I'm using the example from the roster form. I have 1, 4, 9, 16, and they're all perfect squares. So if I use a set builder notation, I'll be saying for all set of all real numbers x such that x is a perfect square. All right? So instead of listing 1, 4, 9, 16, 25, 36, 49, and so on and on and on, I can simply give a description of the variable that's involved. Right? What is the variable? X. And it includes all real number values. And what is the condition? The condition is that x must be a perfect square. Right? Okay. So let's look at this. N is a set of even natural numbers that are less than or equal to 12. So we're going to write this in roster form and in set builder notation. How do you write this in roster form? Kyra?
Open double brackets.
Okay, what is the name of the set?
The set of
What is it? The set has a name. It's part of the question. If you look carefully, you'll see it.
numbers that are
That's the description. Yeah, Kayla?
Even natural numbers.
That's the description. Yeah?
It would be, well, it's kind of same as there, but even natural numbers are.
No, it's just-
You guys are missing the most obvious thing.
Just be N.
N. Yeah, exactly.
Wow.
All right? So N equals 2, 4, 6, 8, 10, 12, because I'm only interested in even natural numbers that are less than or equal to 12. Okay? Now, how do I write this in set builder notation? Wilson, do you want to give it a shot?
set builder.
Mm-hmm. I can, let's see if I can do a dual page so you can see and use that as your format. You with me, right, Wilson?
Yeah.
Okay. Morgan?
Would you do N line N? Oh, N line N is even natural numbers.
Okay. How do you say it? Again, look at the previous page. Although you write it as N line N, whatever it is.
Set of all real numbers N, such that N is even natural.
Okay, just one correction. Now remember, N is the name of the entire set.
You said this, so-
So you would say N equals, you can give a variable, you can give your own, name your own variable, and then you're defining the variable, right? In this case, I'm just using X. So it'll be X. So all real values such that X is then even natural number. And there's one more limit that you need to set. What is that?
Less than equal.
It has to be less than or equal to 12. Because if I don't say that, then I'm going to list all the even natural numbers. Okay? So this actually has, you're starting with something very general. Okay? And then you're trying to narrow it down. So you're starting with all real values. And then you're narrowing it down to even natural numbers. Then you are even narrowing it down further to values that are less than or equal to 12. Okay? Now, why wouldn't this include negative values?
Because
Well,
natural numbers are only positive.
okay, natural numbers only positive 1 and up, correct? Okay. Does this make sense? Okay. Now, you can also write inequalities using set builder notation. So let's solve an inequality. Right? So n minus 4n is greater than 21. Henry, you with me? Okay, eyes on the screen. All right, what is the first step? Kayla?
N equals 9 minus 4, which is greater than 23.
What is the first thing I do, Kayla?
Because you, like the last page,
Just do this. This is an inequality. I don't know what the value of n is yet. So I have to simplify, solve for n, and then write my answer in set builder notation. Go ahead. What is the first thing I do?
Oh, you subtract 9.
I subtract 9 from both sides, correct? Come on. Okay. All right, and then the 9s cancel. Come on. Okay. And then, now what do I have? Negative 4n, don't forget the negative. Negative 4n is greater than 12. Okay? I divide both sides by negative 4. Right? So negative 4 and negative 4 cancel. Okay? That leaves me with n is less than negative 3. Why, Quincy? Why am I switching the direction of the inequality?
Because you divided both sides by
A negative value, correct? When I multiply or divide both sides by a negative, then I have to switch the direction of the inequality. All right. So when I have that, that's how I write my set builder notation. So for all real values of n, such that n is less than negative 3. Does that adequately explain your solution?
Yeah.
Right? So here's a, yeah.
When you're solving the inequality, all you have to do is just put the answer into the notation.
That's one way to look at it. So instead of graphing, if I asked you to write in set builder notation, you can just do this, and that would take care of, it would substitute instead of the graphing. I see the smiles.
Just like,
Yeah, why not?
and so
You can do that?
Is when it says check, write in set builder notation and graph.
And graph and check, right? Okay.
That's when the problem happens.
All right. What should I do here, Annie?
You would add 12 to both sides.
I would add 12 to both sides, okay?
So you would have negative 3y is less than or equal to negative 6.
Okay.
And then you would divide by negative 3. So I keep talking.
Keep talking.
So you would divide by negative 3, and you would get y is greater than or equal to 2.
Good. I'm glad you remembered to switch. So y is greater than or equal to 2. Good job. And how do I write this in set builder notation? Lulu.
Okay, so you would do open bracket,
Okay.
y dash y is greater
No, yeah, you don't want to say y dash y. What does that dash or that line stand for? For all real values of y, such that
y is greater than or equal to 2.
all right. Okay.
That was it.
There we go. Right, for all real values of y such that y is greater than or equal to 2. All right. Right, we started talking about this on the first page. So set A is considered to be a subset of B if each element of A is also an element of B. So here's an example. I have B and I've given you some random values, negative 3, negative 1, 0, 2, 5, and 9. And if I have A, which is negative 3, 0, 5, is A a subset of B? Yes, because every element in A is part of set B.
So if there was like the number 4 in A,
Then it would not be a subset. No. Right? And that's the notation that you use, and we're going to learn a few notations over the next few days. So the first notation that you'd learn is the symbol for the notation for subset, which is C with a line underneath. And when you see that, you know that you're talking about A being a subset of B. Sam?
No, I just answered my own question.
Okay.
Good job, Sam.
All right. Now there are also we're going to learn about a few sets. There's also something called an empty set, okay, or a null set. How do you show an empty set? What is it?
Just like two brackets.
Just two brackets, yeah, or two double brackets.
Was that right?
All right? Yes, you're right. Or a zero that's crossed. Okay, either of those mean that you're talking about an empty set or a null set. It doesn't mean nothing. Okay? It means that that is part of that, and we'll get to that in a second. All right, and the interesting thing is, an empty set is a subset of any set.
Even other empty sets?
Even other empty sets, yeah.
All
All right. So if you're asked for on the next page, you will say, we're gonna list the subsets of a set. Okay, and guess what the first set you're going to list?
Empty
Null set, yes. Annie?
So for the top of the page,
Mm-hmm.
could -3 be a subset of B, or does it have to be more than one number to be?
You
a
tell me.
subset?
Because that's a good springboard to the next.
The word
Next
set
part.
kind of implies that it's more than one number, but there's like a set.
How confident are you?
Not that.
Okay. No, the fact that you even asked that question, if one element, let's say we didn't have the 0 or the 5, and you only had -3, would -3 be a subset of B?
Yeah.
Absolutely.
An empty set is
If an empty set is a subset of that set, why can't, right?
One number.
One number, exactly.
One number is more. One number is
More than
All right. So we're going to talk about finding subsets. All right.
Oh, this is gonna have a lot.
Well, wait till the next one. Do you want to take a guess and tell me how many subsets this set might have?
A lot.
Quincy, you know me. I don't take that for an answer, right, Quincy? Okay. Yeah?
6.
6?
Yeah.
6? Anyone wants to go higher than 6? Yeah?
I go 7.
7.
7, 'cause
Andrew?
I think it's, yeah, 7.
How many of you actually counted?
I'm actually
Oh, interesting. Okay. Anton, so you just guessed. You didn't count.
I counted.
You counted?
My first
Okay, so 6, 7. All right, let's see. So what is the first subset of the set?
no.
Alex?
7.
All right. Null set.
There's the other
Okay, then we're going to list the individual elements. So it's going to be 7, 8, 9.
That's
Okay? Then we're going to look for pairs. 7, 8, 7, 11, 8, 11.
Isn't this a fact?
And then I have 7, 8, 11. So how many do we have?
You can count the same one as a subset
Why not?
itself. Because it's like,
I
I guess, but it kind of seems like cheaty.
Cheating? Cheaty. All right, so how many sets do you have? 3, 6, 8. You guys are pretty close. All right.
We knew what we were doing.
All right. What are the subsets of that? And how many? Okay, before you count, maybe you should count. I'll give you 10 seconds to count and then tell me how many we would have.
Wait, can't you?
Just do it in your head. You don't have to talk. Another 5 seconds.
Oh, I got it.
Oh, I forgot those.
You don't have to open your mouth and talk to count, right? I mean, I don't know how.
I got it.
All right, someone hasn't answered. Wilson.
12.
12. Anyone wants to go higher than 12?
Oh, yes.
It's high.
Quincy.
26.
26?
Yeah, 12. 12. 14.
Okay.
I got
Wait, 14.
14?
15.
12. 14.
15?
15.
15.
All right.
15 is the magic number.
Quincy, you want to give it another shot?
Okay.
Okay. All right.
10 or 12 or 11.
No,
11,
it's
10,
10, 11. Okay. He went up to 15. Quincy doesn't want to go one up and say 16. Okay. All right. Okay. Let's do it. Okay. Do you want to help me?
Yeah.
Okay. Henry, start with the first set. First subset.
Null set.
Null set. Okay. Good. All right. Next sequence of sets. Sam?
0, 1, 2, and 3.
Okay, so those are all individual subsets. 0, 1, 2, 3. All right.
Multiplying you've got to do.
Yeah, no, there's four different numbers.
Then you missed the null set.
Yeah, just like different
It's
versions
gonna
of
be
sweet
5 and
and
You guys want to go outside and talk and then come back? Okay. All right, and then Kayla, list the next
It's going to be 0 and 1.
0, 1,
And then there's going to be 0 and 2.
0, 2,
And there's going to be 0 and 3.
0, 3.
And can I keep going?
Keep going.
And there's going to be 1 and 2.
1 and 2.
And there's going to be 1 and 3.
Okay.
And then.
You're on the right track. Keep going.
And then. I said that already.
No, you didn't.
But I said 3.
No, you said what? Oh, and one. Oh, and
All right, you said 0, 1, 0, 2, 0, 3.
1,
1, 2, 1, 3.
2, 3.
Okay, 2, 3. All right. There we go. Good.
1, 2, 3.
Yeah.
4, 5, 6, 7, 8, 9, 10.
Oh, and then there's a.
Oh, you forgot the.
How many do we have?
Oh my god, the
And
3.
you guys forgot the please.
Okay, what about the triples?
Who's that anything about? That's what I forgot. 16. It's going to be 16.
Oh.
0, 1, 2. 0, 2, 3. 0, 1, 3. All right. Now at this point, I think you should stop counting and focus on the pattern here, so we don't leave out anything. Okay.
1, 2, 3.
So 0, 1, 2, 0, 2, 3, 0, 1, 3, and then 1, 2, 3. Now, so I've used all the triples. And what is the last one? All right, the full set, which will be 0, 1, 2, 3. Yes.
I think I got.
You have the pattern? Okay. Anton thinks he has the pattern.
Can I just see what the answer is? The 5 numbers.
Sorry?
Can I just see what the answer is? The 5 numbers.
Okay. I don't know.
Oh, you don't know.
I don't know. But let's use the 2 and the 3. Oh, 3 and the 4, sorry. So what is your formula?
It's you count the number of numbers there are. So if there's 4 numbers, then you multiply 4
Okay,
times.
I want to use the right terms. Thanks, Louis.
I know his theory and I can use it right.
Okay, use the right terms.
So the square of the amount of numbers in
Numbers,
Integers.
no. Yes. Elements, yes.
elements inside the brackets minus 1.
Minus 1.
Minus 1.
It worked for 3 and 4.
Okay, so 3 squared is 9.
15.
Wait, can we scroll up?
So 9 minus 1 is 8. 4 squared is 16.
Minus 1 is
16 minus 1 is
15.
15. So
No, it's because it doesn't count the
No, but
single
that was
bracket. It doesn't count the nothing bracket.
nothing bracket.
Oh,
Okay, guys, listen.
I didn't count the bottom one.
No, you. Okay, now when you are at this level, you can't talk like 4th grader. Do you understand? So when you give me an answer like, oh, what did you say, Quincy?
26.
No, before that.
Oh, he said a lot.
A lot. Okay. Let's move away from that. Okay. And you have certain terminology that is given to you, and you're looking at some of those terminologies and use them. Don't say nothing said. That's not a set. All right. Okay. So I have 2 sets that are given in set builder notation. The first one is all real values of x such that x is less than -3. And set B is all real values of x such that x is less than or equal to 0. The question is A a subset of B? Well,
Yeah.
Why?
Because anything that's less than -3 is going to be less than Regis.
All right, so let's list the values. So if I were to list the values here, give me 1 second. Okay, what would it be?
It would be anything from -4 to -infinity.
Okay, so negative
For
infinity,
A.
right? Then I have -5, -4. Okay, this is supposed to be the four. Okay, all right. And then what would this set B be?
It would be anything from -infinity.
Okay, negative infinity to -3, -2, -1, including 0. Okay? So the question is this a subset of B? And the answer is yes, because every element in set A will have a corresponding element in set B.
The only things that differ are
Correct.
-2, 1.
Okay. All right. So we talked about empty set or null set. We're going to talk about the universal set. What's the universal set? Universal set, as the name suggests, is the entire set